Good day, dear all. My name is Orwin Rivas, and this video is corresponding to the activity number 3 of International Physical Distribution. In this exercise, we are going to see some sceneries about a company which exports products of fig, mud, and wool to different cities in the world. The company is called Artesanía de Colombia and has three warehouses located in Ibagué, Bogotá, and Tunja. Weekly, they send products in boxes to their customers in Madrid, Tokyo, New York, Berlin, and Paris. And for the transportation from the warehouses to the ports, they use trucks. And then in the port, the cargo is loaded to the ships. And the ships arrive to the nearest port to the destination cities. It can be the warehouse or any other place that the customer requires. So we have here, this is the distribution channel. So we have the 3 warehouses, the 3 ports that we are using for this exercise, and we have the cities which receive. So the company has some limits of units per warehouse. So we have here all this. And this is the demand limit that these cities require. So what we are going to make is the transfer to each of these places. And we have the price, the cost here. From Ibagué to Madrid, Ibagué Buenaventura. You see the prices here. So we have 4 scenarios. So we have to solve all of these and to find the lowest cost of sending using the mathematical model. So we are going to solve in this. So we have the first scenario. So this is the same image in the Word document. So we have here some conventions in order to abbreviate and get the exercise easier. So we have, for Ibagué, we have the I, for Bogotá, the B, and you see here, each node has a city and a letter assigned. So this is what we do. In this scenario, what we do is to locate this table here. So we have the main location of the boxes. From these ones, we transfer to this, and we have the cost. And this is the units distributed in that transference. So what we are going to do here, we have this table where we have the result of this and where we find the lowest cost of sending. So what we do, this transferring places always will be positive and this negative because we pass from here to here. So we have for Ibagué the lowest limit. Okay, this LS lowest limit, demand limit, slack. Slack is what will determine if we're complying or not with the demand. So what we do is to make an addition of all connections of the nodes. For example, for Ibagué, we make a sum of all of these. You see, Ibagué. For Bogotá, we do the same. We sum all of it where Bogotá is the principal transferring point. And if we find any other related connection with Bogotá, we find here, but here is in minus, so we take it out from here. This is the minus, you see? And we do all like this. For Buenaventura the same. We make for Tunja, we have here. Yes, for Tunja we have here. For Buenaventura we have the sum of all these. You see Buenaventura is first here, and the other connection with Buenaventura, we make the rest. And we do this with all ports. We sum the main connection. You see Cartagena here, and the other connection with Cartagena located on the right side will rest. Look, they are here. So the lowest limit is what we see here. And in order to see if the exercise is well organized, this must be the same like this. This lag, as I told you before, and this, as this point, this is the demand limit, and these are the demand made by all the ports. These are only destination ports? All is minus because they will receive, they do not transfer. So this, the picking of the first transferences of this exercise were made checking the lowest cost. Ibagué to Buenaventura, if we see Ibagué has plenty connections, but to Buenaventura is the lowest cost if we make the comparison with this. The same from Bogotá to Buenaventura also is the lowest cost. That's why we choose here. From Tunja, we have, as we have already transport plenty cargo to Buenaventura, we have to choose different ones. So we have here Cartagena and Barranquilla, and all this cargo from Buenaventura, which is already here, we pass to the different places. Buenaventura to Madrid, this is 1,100 boxes. From Buenaventura to New York, 2,200 boxes. From Buenaventura to Berlin, 1,550 boxes. And here from Cartagena to Tokyo, we take this. Why we have to choose? You have to choose here because as we have all these connections. We choose here from Cartagena to Tokyo. We do not send to Madrid because we already sent to Madrid from here. We do not send to New York because already we comply the demand here. And Berlin we also comply the demand, so we have to pick Tokyo here. And from Barranquilla to Paris because any of these send to Paris. So here is the exercise. As I explained you before, we sum all the positive and rest all the negative. So the minimum cost for this is $91,260 US. You see, this is the difference. We are not complying with the demand of this. So all of this will be sent by air transportation. So the company would earn more money if they could transport all these boxes, the resting boxes also, from these ports. Because when they use air transportation for this, of course will be a higher price. So we have a second scenario here. In this, the Port of Buenaventura is stopped due to workers' strike. So we have to redistribute here. We already have the formulas. So we make the shifting depending on the lowest price. So we take from Barranquilla from Ibagué to Barranquilla. We choose here Barranquilla because of the second connection. Cartagena is lower, but the second connection here will be better than from Cartagena to any other place. So we pick from Bogota to Cartagena here. Then we pick from Tunja to Barranquilla, because you see these red ones are Buenaventura, but we cannot use it. From Cartagena to Madrid. So as we see, we are also having this case here, and the minimum cost of sending is 1,167 US dollars, 11% of over cost in comparison with this first scenario. So this is this workers' strike at Buenaventura affected a lot the company profitability. 11% of overcost here. So we have third scenario, A and B. The difference with this is that we cannot transport more than 1,500 boxes through any of the ports. So we take all this. This information was given in the Word document we have here, so we just passed. But the only difference I have here, all what we passed from the exercise, from the Word document, and these ones were not given by the document. So why do we pick these quantities? Because if we see, Madrid and Tokyo are already receiving, you see, New York, Berlin, Paris. And if we take this out, we have two mistakes here. This is the one you see. So in order to be able to achieve this, we have to put these two numbers here. And the minimum cost of sending is 95,135 US dollars in comparison with the first scenario. So we have an overcost of 4%, just for decreasing the quantity of boxes to be sent by each port. And here we have the same limitation, but also we have Buenaventura port which strike. So we have again to redistribute, and of course using the lowest cost. So we have here, we cannot use Buenaventura for any of the transferences. So we made the shifting. Ibagué to Cartagena, Ibagué to Barranquilla. The maximum we can transfer here. Bogota to Cartagena, the maximum also. Bogota to New York. Why like this? Because then we comply. So from Tunja to Cartagena, we send 1,000 pieces. From Tunja to Barranquilla, 1,500 pieces. And we have all here. Cartagena to Berlin, Barranquilla to New York, Barranquilla to Berlin, So we have the table here, and as we see, in all the exercise, is always the same accumulated slack. And the minimum cost of sending, which these two big problems, workers' strike in Buenaventura and the decreasing of the quantity of boxes that we can send, the minimum cost of sending is 103,522 US dollars per box.